Hello and good afternoon. CTS265, Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course based on version 7, and in this video tutorial we're going to be taking a quick look at manipulating routing redistribution. And so again, another phenomenal activity here from the Cisco Learning Labs portfolio. So let's go ahead and jump in. So step 1 is asking us to configure redistribution from OSPF into EIGRP using a distribute list. So we're going to do a couple things here. We're going to define an ACL that's going to filter out the 10, 10, 21, 22, 23, and 24 networks. And we're going to do that at the point of mutual redistribution, which is router 1 right here. So on router 1, if I go from user exec into privilege exec and I say show IP route, you can see that we've got a number of EIGRP routes. And let me go ahead and trim this down. So I'll say show IP route EIGRP. So there's our EIGRP routing information. And then show IP route OSPF is going to show the OSPF routing information. So what we want to do is we want to deny the 1010, 21, 22, and 23, and you can see that that information is right here, and the 24 as well. So we want to deny this information from being redistributed from OSPF into EIGRP. So let's go ahead and make that happen. So the first thing we're going to do is go into global config, where we want to create an access list. So we're going to go with just a standard numbered access list. So we'll say access list 5 deny 10.10.21.0, and then we'll put our wildcard mask on here for /24. And we're going to repeat for the 22, the 23, and the 24. And again, remember that we are manipulating the redistribution from OSPF into EIGRP. So if I were to say do show run section EIGRP, you can see that we have a redistribute statement here, and actually that's for the OSPF. And here we go. We're looking for the redistribute OSPF 10, right? And that's the OSPF process. And you can see that we're redistributing the routing information from OSPF 10, process ID 10, into EIGRP. And if I were to say do show run section OSPF, you're going to see that here is my router OSPF 10 statement. And again, we're simply redistributing EIGRP 100, which we were just looking at up here, into OSPF as well. So we've got mutual redistribution going on here. So now that we have the access list, we've got the deny statements. However, there's an implicit deny at the end of every access list, every prefix list, every route map. So if we don't want to block all of the information, what we need to do is we need to add in a permit any. And so let's go ahead and see what would happen. And if we take a look here at R2, so let's look at R2, right? Because remember, we're talking about redistributing all of our OSPF information here on into the EIGRP autonomous system. So we'll go from user exec to privilege exec into global config, and I'll say do show IP route EIGRP. And you can see that the 21, 22, and 23, and 24 are being redistributed as external EIGRP routes. Now, there also is additional routing information here. We have these 172.16s, 11, 12, 21, 22, 23, and 24. So if I were to forget my permit any statement at the end here, what would happen? So I'm going to say router EIGRP 100, and we're going to say distribute list, because we're going to create this distribute list here, distribute list 5 out OSPF 10. And so what I'm saying is I want to apply distribute list 5, and the 5 references the access list number that's right above it there. So I'm going to apply the distribute list 5, which refers to the access list we just created, in the outbound direction on router 1 for the routing information that has been redistributed from OSPF process ID 10. And again, to see what information that is, we can look right over here and we see all these external EIGRP routes, and these are the ones that have been redistributed in. If I were to say, let me pull this back here, if I were to say do show IP route, let's say 172.16.11.0, we can see that it's known from EIGRP. The distance is 170, and what kind of a route is it? It's an external EIGRP route. Now, where did we learn it from? Well, we learned it from 172.16.3.1, which means we learned it from router 1. And again, it's being redistributed via EIGRP 100. All right, so let's go back over here to router 1. We're going to hit enter. We'll come back to router 2, keeping in mind that we did not put the permit any at the end of that access list. So now when I say do show IP route EIGRP, and this is perfect timing, you can see we have our graceful restart there, right? So it's a quick resync of the information, which is hitless. And where is all my EIGRP routing information? Specifically, what happened to all of these EIGRP routes? Exactly, they're gone. Because on router 1, when we created the access list, I said deny 10, 10, 21, 22, 23, and 24. However, there's an implicit deny here that you don't see at the end of every access list, every prefix list, and every route map. And what that's doing is it's denying all, right, or deny any. So what do we need to do to resolve the issue? We need to come back and say, let's get the access list back up here. So access list 5, and at the very end, we've denied the first 3 routes we want to, or the first 4 routes we'd like to deny. So now I'm going to say access list 5 permit any. Now, let's come back over here to router 2. Are we going to see anything at all? So I've changed the access list, and there we go. It took it a couple seconds, but now we can confirm that we see the information on router 2 that we would anticipate we're going to see, which is all of the 172s. So we've filtered out the 10 dot addresses. However, we have allowed the 172.16s to be advertised. All right, so now let's go ahead and let's do this exact same thing on router 1. We're going to go ahead and we're going to do this with a prefix list now. So we just did it with an access list. Let's go ahead and on router 1, we're going to do it with a prefix list. So I would say IP prefix list, and I can give it any name that I want here. So let's just say ABC. And then what do I want to do? If I don't put the sequence number, it's going to start at 5, and we're okay with that. So I want to deny. Now, this is interesting, and here's where the prefix list can come in handy. When we take a look at these routes, 10, 10, 21, 22, 23, and 24, if you think about it almost in terms of summarization, these are all /24s, but what do they all have in common? Exactly. The first 16 bits are they all have the first 16 bits in common. So I could do a single prefix list here. I'm going to say deny 10.10.0.0/16. Now, if I leave it there, if I were to only say deny 10.10.0.16, what would happen is that would only deny routes that start with 10.10 and have a /16 prefix length, right? Now, none of our 10.10 routes up here are /16. So, what do we need to do? Well, this is where we call into action the range commands, the greater than or equal to or the less than or equal to. So what we're saying with the statement here, this 10.10.00/16, is whatever I'm matching, the first 16 bits have to match identically. So they have to start, whatever I'm going to match, it's going to start with 10.10, and then it can be anything dot anything. And if I say /16, I could say less than or equal to 24. Now, see, we say less than or equal to 24. Now, the challenge here is that if I say that, I'm going to be matching /16s, 17s, 18s, 19s, 20s, 21s, 22s, 23s, and 24s. Now, if the restriction is that you have to match, and we'll scroll back up here, these 4 routes and only those 4 routes, this would do it. And if I added to the restriction that it can only be /24s, there's a way that we can indicate that. And the way that I do that is I say greater than or equal to 24 and less than or equal to 24. And so what this construct says is the first 16 bits need to be 10.10 or equal to 10.10. And that's what the /16 locks us in with. So it has to be 10.10 because the /16 says the first 16 bits have to match identically. The greater than or equal to /24 says that it should be /24 or greater. However, when I put the less than or equal to 24, this construct right here says exactly /24. Now, you may be wondering, why didn't I say 10.10.0.0/24? Well, the reason we didn't say that is because then the first 24 bits would have to match, which would mean I would be looking for the specific single subnet 10.10.0.0/24, and that would not match what we're looking for. So, this construct here in a single line allows me, because I'm using the range, allows me to consolidate those 4 statements right there into this single statement. So now let's go ahead and let's apply this statement. Let's jump back into the router EIGRP 100. Say do show run section EIGRP. And we're going to say no. And where is it at? I'm missing it here. I'm sorry, no distribute list. There it is. No distribute list. They're not going to cooperate. There we go. No distribute list 5 out OSPF 10. Right? So now we should see a graceful restart here. If I slide over to router 2, we've pulled the distribute list off. Actually, no restart. It just simply allows the information back in. So now you can see we've removed the distribute list, right? So it's no longer impacting these routes that are being redistributed. Let's apply it now again here, and actually we did get the resync. Okay, we didn't see it on router 2, but we do see it on router 1. All right, so let's go ahead now and say distribute list, and what do I put here? Do I put a number? I don't. I put prefix and then the name of my prefix list. Very similar to when we do the route map. Remember, in the route map, when I say match IP address, if I put the word of the prefix list next, I'm actually putting down what the parser, the iOS command line parser, is going to take as an ACL name. So it's the same thing here. I need to make sure I put down prefix because I'm using a prefix list. The prefix list name is ABC, and we're going to do it in the outbound. Oops, sorry, we did not want to hit enter there. We're going to do it in the outbound direction for OSPF routing information that's being redistributed from OSPF process ID 10. So we put that on there. Let me make sure, because I hit enter there a little early. Do show run section EIGRP. Let's make sure that we have and that we do have a bogus statement there. So we're going to say no distribute list prefix ABC out, and then we need to rerun this again. Let's make sure. Okay, so there we go. So distribute list prefix ABC out OSPF 10. The line that we have right here, we basically consolidated, and there's our resync. We basically consolidated do show run include prefix. the 4-line ACL has now been shrunk down to a single prefix list. Now let's come over to router 2 and let's see, do we get the same result that we think we're going to get here? We had the graceful restart, do show IP route EIGRP, and we have nothing. So why do we have nothing again? Exactly. At the end of every prefix list, there's a what? You've got it. There's an implicit deny. So when I denied that range, the very next statement is going to deny everything. So what do we need? Exact same challenge we had before with the ACL. So I'm going to say prefix list ABC permit, and what am I going to permit? So I don't say permit any, right? If you can, as you see here, there's no keyword. I can't say any. So what I need to do is I need to say everything else, which is 0.0.0.0/0. Now, if I left it there, what am I saying I'm permitting? Exactly. If I hit enter right here, I'm only permitting the default route. So what I need to do is I need to say 0.0.0.0/0 less than or equal to 32. And what that means is permit all IPv4 addresses. So we've denied or filtered out the 10.10s that we wanted to get. Now we add in this additional prefix list statement here. So if I say do show run include prefix, let's take a look. So there we go. Sequence number 5 is going to deny the 10 dots I wish to get rid of. And sequence number 10 is going to allow everything else through. That way, we don't end up with a blank routing table. However, what's happening here? It's still allowing everything to come through. And the reason for that, and I apologize, these came through, I thought they were /24s. These came through as /32s. So I was blocking the 24s. How do we deal with the 32s? And exactly the 32s. So this is where I can say IP, prefix list, ABC, sequence number, and I'm going to insert this into the chronological order first and say deny, and let's say 10.10.0.0/16 greater than or equal to 32, less than or equal to 32. And let's step back over here to router 2, and let's see, did that do? And we'll give it a second here. And there we go, right? So we gave it a second to do the resync, and that did exactly what we wanted it to do. So let's go ahead and make sure we clean up here. I'm going to say no IP prefix list ABC sequence number 5. And whoops, sorry, sequence number 5, deny 10.10.0.0/16 greater than or equal to 24, less than or equal to 24. Because those came over as /32s, so they have been denied. So now let's say do show run include prefix. So now we have our prefix list here. We're denying the 1010s and greater than or equal to 32. And then we have our permit any here at the end. And this actually achieved exactly what we wanted it to. It's blocking all of the 10 dots. All right, so if you're following along, we're going to move on to step number 3. So we're going to edit the redistribution from EIGRP to OSPF on router 1, and we're going to add a prefix list to the distribute list to advertise all matching prefixes. Of the 172.16.0.0/16 range, all the way to /24. So let's come over to router 4, go from user exec to privilege exec, and let's say show IP route, and you can see all the OE2. So let's trim this down. So we'll say show IP route let's say show IP route OSPF, and that gives us a much better view as to all the OSPF routing information. So we're going to do the opposite this way. We're going to grab all of the 172.16 information and we're going to filter this out. So all we should be left with on the router 4 side is the 10.10 information that's being redistributed. All right, so how do we achieve this? Well, let's go back. Remember, we can't do the filtering here on router 4, and we don't want to do it here on router 3. 3 is an ABR. It's external routing information that we're looking at getting, so we're going to do it on router 1. So let's go ahead and create a prefix list here on router 1. It's going to say IP prefix list, and we're just going to say EIGRP, and I like to do an arrow, into OSPF. We'll set the sequence number at 5, and we're going to permit the 172.16.0.0/16. And actually looks like we're going to allow the 172s and block the 10s. We'll see what develops here. Now remember, we said from 16 to 24, so I'm going to say less than or equal to 24. And what that means is the first 16 bits of anything this is going to match have to be 172.16. And then the last 16 bits can be anything as long as the mask is a /16, 17, 18, 19, 20, 21, 22, 23, or /24 inclusive, including that /24. So anything between a /16 and a /24 that starts with 172.16 is going to be matched here. All right, so there's our single prefix list. Now let's go ahead and say router OSPF 10, because remember, we're talking about the information that's being redistributed from EIGRP into OSPF, and we're going to sort of nip it in the bud right here on router 1 as it's being redistributed into the OSPF process. So I'm going to go ahead and say distribute list, and the same rule applies here, right? I need to say prefix for the prefix list, EIGRP into OSPF, and in which direction? Remember, in the outbound direction from process EIGRP 100. So I'll hit enter here. Now let's step back over to router 4. And again, so I was thinking they were going to filter the 172.16s out with a deny. However, they used a permit, so what would we expect to see? Exactly. We would expect to see the 172.16s. Now, very important here, you'll notice that we had these two routes here. Or actually, I'm sorry, we'll go up to these 3 right here. 172.16.42/26, 42. There's another /26 and another. There's 3 /26s. How come those didn't match? Why did we only match these first 3 routes right here? Exactly, because we ranged the prefix length between 16 and 24. We didn't go up to 26, so these would not match. Now, if I were to go back to router 1, and if I were to exit out here and say no, and IP, say no IP, prefix list, EIGRP to OSPF, sequence 5, permit 172.16.0.0/16 less than or equal to 24. If I didn't do that, and I said less than or equal to 26, and let's put this back in. First, let's look at router 4 here. So router 4, you can see it sees everything again, right? All the 10 dots and those 3 172.16s that have a /26 subnet mask. So now I've changed on router 1 here, I've changed the statement to say less than or equal to 26. So now let's go back over here to router 4. And now we do match the 26s, as you can see there. So instead of just the 3 /24s, I now get the 3 /24s and the 3 /26s. And again, that's where the range becomes extremely convenient. So on router 1, if I were to take a look at, let me click in here. If I were to take a look at do show IP prefix list detail, what do we see? So we've got the prefix list ABC, which we had used before. Now we also have the prefix list EIGRP to OSPF. And this is the one that we're working with right now. you can see we've got a count of 1. Let's see, the counter should increase. Well, actually, no, the counter is going to stay 1. Excuse me. Because we have one network that's going to match. Look at the count, the hit count down here. So the hit count is 5 because we have 5 routes that we've matched, right? So if I come back over here, we've got, actually we have, it's an enter area, sorry, enter, 1, 2, 3, 4, 5. So there's the 5 external OE2 routes that we've matched, and that's why we see the hit count at 5, right? Now the reference count, this has something to do with the memory blocks or something like that that the prefix lists use. So these are not really germane to the conversation right now, but know that it has something to do with the internal memory process and the way that the prefix list tracks the memory blocks it's using. But again, the key here is the hit count is 5 because we've had 5 matches. Had I run that when it was less than or equal to 24, it would have said 3. Let me take a quick look here. It would have said 1, 2, 3. Yeah, it would have said 3. All right, so that's using the distribute list. And what we also see here, and this when we did the lab, you'll also notice we see this inter area, this type 3 LSA. Now, this does match, right, because it is a /24, so it falls within that prefix length range. But again, the distribute list in the outbound direction into OSPF is for external information and coming from external routing sources. All right, well, this is going to wrap up discovery activity number 16, where we took a look at manipulating the redistribution of routing information. We looked at prefix lists, we looked at ACLs, and we saw how those can be leveraged by the distribute list command within the respective routing process in order to filter routing information out that you don't want to have redistributed into the domain that you're redistributing it into. All right, thanks for watching, and I will see you guys on Monday.